everyone, welcome back to the channel Kanu Sir, and I am your teacher Pawan Kanu, and I am back again with the previous topic of finding LCM and LCM. And here now I am getting some difficult questions which students can't easily find out the solution of it. So let's solve the question directly without wasting any more time. So the first expression given in the question is, first expression I'll write in short exp, that is x minus y whole square plus 4xy. And for some of the students, if you know the formulas very carefully and clearly, then you can understand it is also a formula. But for others who don't know whether it is a formula or not, you can open this in a simple way, like x minus y whole square. You can write x square minus 2xy plus y square. We have opened the formula of x minus y whole square plus 4xy, and x square minus 2xy plus 4xy will give you plus 2xy plus y square. And again this term looks like another formula, that is x plus y whole square. And I told you in the before also that this formula also looks like a formula. Now you can remember the term this equals to a formula, that is x plus y, and you can keep x plus y whole square in the form of product so that they look like a factor of this expression. Now next is the second expression, and in second expression you can write the question first, that is 2x cube plus 4x square y plus 2x y square. And in a previous video I have explained you that while doing the factorization of the expressions, try your best to do the first step of factorization, that is to find a common number if there is possible, or a common variable if there is possible. So the possibility of getting number common, that is 2, because there is 2, 4 and 2, all of them are the multiple of 2, so you can take 2 common out of the expressions. And x cube, x square and x is also common variable in the expression. So we can take one x common, then we'll find here x square left in the first term plus 2 times 2 is 4, x is already out, xy plus 2x is out and y square is left, we'll write here y square. After that, this term looks like a formula as the previous we have done, that is x plus y whole square equals to 2x, x plus y and x plus y. Now while finding the HCF, you have to check which is the common in both the expression, that is x plus y is common and one more x plus y is common. So we'll be writing both x plus y plus x plus y. And while finding the LCM, first we have to copy the HCF. Always copy HCF in the LCM and find out the term which is not common. Here everything is common, but here 2x is not common in both of the expression. That can also be written here in the term of LCM, and hence the value of HCF and LCM is concluded. Now let's go to the next question, and if you have any problem, feel free to write the comment in the comment section, and I will come to know whether or which term or which step is not understood to you. Now let us go for question number 2. In question number 2, you can see there is another 2 expressions given, and let's start from the first expression, that is first expression is equals to x power 4 plus 4. So similar type of questions I have done in the previous video also. What can we do best is that we can change that term in the form of the formula a square plus b square, that is equals to a plus b whole square minus 2ab. And let's change this expression in the form of a square plus b square. So here you can see x power 4 can be written as x square whole square as a square, and 4 can be written as 2 square in the terms of b square. Now if you place this formula in this, then you can write like a plus b whole square minus 2a and b. So here you will get x square plus 2 whole square minus 2 times 2 is 4x square, which can you again change into a formula. 4 and x can be changed into 2x whole square, because 4 can be changed to 2 square and x square can be changed to x power 2. And again you have to use the second formula, that is a square minus b square, that is a plus b, a minus b. So whenever you use the formula a square plus b square, in almost all the cases you have to use a square minus b square formula followed after a square plus b square. So after formula number 1, formula number 2, almost in all the questions you have to apply. So this all x square plus 2 will be act as a square and this will be like a b square. Then we are going to compare and write the question in the terms of formula, like this is as a and this is as b. So we'll write a plus b, and again we'll write a minus b. You can arrange the terms in the descending order, like x square then 2x plus 2. It means the power of x is decreasing, and similarly here also x square minus 2x plus 2. Now this is about the first expression, and in the second expression we have 3x square plus a minus 6x plus 6. Then as usual I have explained you 3, 6 and 6 are the multiples of 3. So we try our best to take first common numbers out so that our factorization will be as simple as possible. So taking 3 common, we'll get x square minus 3 times 2 is 6, x plus 3 times 2 is 6. And you can check here, the terms are almost matching, so we don't have to factorize anymore because they will not be factorized also. Therefore, HCF is equals to the common in both, that is, this term is common in both the cases, so we'll write x square minus 2x plus 2. But when we talk about the LCM, then we have to write first the common term and also those uncommon terms also. So like as x square minus 2x plus 2 is common, so we copy it first, and remaining those non-common terms like x square plus 2x plus 2 and 3 is also not common, so that is also copied here. So you can understand the value of HCF will be smaller one and the LCM will be greater one. Next is question number 3. Here in question number 3, here we are going to learn something different, that we are going to arrange the terms in the expression. Let's see what is there in the first expression. X square minus y square minus 2x plus 1. So here what can you understand, that x square minus y square looks like a formula, like a square minus b square. You can easily put them in a formula and we'll find the answer. But that is not possible because there is 2x and 1. We cannot find any factor from 2x and 1. That is why we have to try to arrange the terms, arrange the variables in the expression. Like we can arrange x square minus 2x plus 1 as one term separately and minus y square as the another term. Then here what can we see? These 3 terms or 3 variables will go into a formula like a minus b whole square formula, that is a square minus 2ab plus b square formula. So let's see how they go in a formula. A square minus 2a, and there is nothing left, but still we can write 1 because 2 times 1 is 2, plus because there is 1, so we can write 1 whole square minus y as a whole square. Now this formula looks like a minus b whole square, so we can change x minus 1 whole square. X is x as a, 1x as b minus y whole square. Now these 2 terms look like a square minus b square, so we can put them in a formula like a plus b. Again a minus b. We can arrange the variables x plus y minus 1 x minus y minus 1. So this is all about the first expression. Now about second expression. In second expression, x square minus xy minus x, just one logic is enough for second expression, that is, if all the variables are common, try to take one of them. So x square, x and x is common in all the terms, so we can take one x common out, then we will get x left here, minus y left, and minus nothing is left because the single x is out. So if nothing is left, it means there is 1 in the term, so we will write here 1, and hence we are almost near to the answer. Therefore, HCF is the factor which is common in both the expressions, that is x minus y minus 1, and rest ordered factors are not common, that can we list down them in a LCM, like x is not common, x plus y minus 1 is not common, but which is common in both, that is x minus y minus 1. So in LCM, first we will try our best to write which is common in both, and rest of the remaining which are not common will also be copied in the LCM. So now let's go for the 4 number. Now in 4 number, here in the first expression we can see there are 4 terms. Previously we did the factorization of just 3 terms. Now there are 4 terms in one single expression, and try our best to arrange this expression so that we can get a correct and clear understandable answer for us. For that we can arrange the terms like a cube minus 1 and minus a square in one term plus a. So we can make a group of 2 like this. So some of the students may get confused that why couldn't we go from directly the same question as it is given. We can go from this process also as it is given. I will do the next process also for that. But always we have to follow this type of cases. Whenever we get one, we try to arrange the one with the highest order of the variable, like a cube minus 1. So you can change this in a formula. We have got a cube minus b cube, then we will get the formula like a minus b, a square plus ab plus b square. Similarly, this also looks like a cube minus b cube, and from here these 2 terms you can take minus a common, then you will get a left here, and because minus is common from the plus also, so you get here minus, and a is already out, so there is 1 left. If you are not clear how it happened, then you can go back. Minus a times a into a, you will get minus a square. Minus times minus, you will get plus, and a into 1 is a. And hence we got correct from this term. Now we have to use this formula from 4 number, like a minus 1 it will be a minus b, and we will get here a square plus ab means a into b, a plus a, and plus b square means 1 square here plus 1 minus a minus 1. Now you can see the second term is expanded in the form of a minus 1, a square plus a plus 1, and the second term is expanded with a into a minus 1. From the both terms you can take common, that is a minus 1 is seen common in both the expressions, then you can write a minus 1, and you can take a square bracket and pull this expression down from the first term minus from the second term, that is a. Again you can open it in a formula like a square plus a plus 1 minus a. Plus a and minus a is cancelled, you will get a minus 1 and a square plus 1. After that we cannot open anymore. If you say this can be opened, then you can check here a square plus 1 square. If you try to open, then it will be like a plus 1 whole square minus 2a. Then you will get a plus 1 whole square minus 2a. and 2a you cannot change it in a square form, and you cannot use it in the a square minus b square form. So you don't try this. It is enough after this step, and now we can go for the second expression. But I have told you we can try this first expression in another way method also. So I'll do it in a short, a square plus a minus 1. But we will have to apply always these terms, because this type of logic will be applicable in all the questions, but not for these expressions. Like a square is common, we will get a minus 1 plus a minus 1 is common because there is 1. Then you will get here a minus 1 and a square plus 1. Actually, you got answer in 3 steps. That is okay. You can see answer is matching just in 3 steps. But here I have used one extra step to make you understand. Then I have arranged this. So you can not try these steps also. Directly in 4 steps you can find the solution. But this solution will be applicable for all questions, and this solution will be applicable only for certain questions. Now let's go for the second expression here. Second expression, that is 2a cube minus a square plus a minus 2. Then from here you can do 2a cube minus 2 minus a square plus a. Then you will get 2 common out. From them a cube minus 1 minus a common out, you will get a minus 1. Same as before here, the condition. So a cube minus 1 is broken in the form of a minus 1 a square plus a plus 1. So you can write a minus 1 a square plus a plus 1 minus a minus 1. Now from the 2 terms you can find a minus 1 common. Then you write a minus 1 and you will have to put the square bracket because there are 2 factors still remaining. 2 a square plus a plus 1 minus a, and a minus 1, and you have to open the bracket now. 2a square plus 2a plus 2 minus a. This way you will get 2a square plus 2a and minus a will get plus a plus 2. Now we have to find the HCF. HCF means the common in both. The factor which is common in both the terms expressions are a plus 1, just 1. And now for LCM you can write first HCF and the remaining factors like a square plus 1, and the remaining factor is here, that is 2a square plus a plus 2. And now you can try this again in a second process, like 2a cube minus a square plus a minus 2. Here you will get, taking a square common, you will find 2a minus 1 plus 1 a minus 2. Now you can see it is not possible by using the same second step which I have did for the first expression. That is why we have to always try to arrange the numbers here. Now let us go for question number 5. Now in question number 5, you can see the question is little bit different than the previous question, and I have suggested in question number 3 and 4 that we can arrange the numbers and we can find the factorization of this given expression. But I want to suggest you that you can carefully see 16a power 4 is completely different from all the 3 terms, and you can arrange 4a square plus 4a minus 1 in a whole square form. Let's see how. 16 can be changed to 4 and a square as whole square. You can take square of 4 is 16, a square will be a power 4. Taking minus common, and you can take 4a square minus 4a plus 1. Again 4a square whole square minus, you can check here, they go in a whole square form of a plus b whole square or a minus b whole square. 4a can be kept as 2a whole square minus 2 from the formula, and if you break 2a, then they look like 2 times 2 is 4a. Because there is 1, then you can put 1 by your side also, because 1 will not affect the value of 4a here, and you can keep 1 as 1 whole square. So let us understand what we did again. 4a square will be kept as 2a whole square, because 4 is the square of 2 and a square is the square of a. 4a will be broken down into 2 times 2a in our name of a formula of 2ab type, where b will be considered as 1 because we have got 1 as b square, and multiplying by 1 will not affect the value of 4a. After that, you can see they go in a formula of a minus b whole square, so you can write a minus b whole square. And I have said you, after using that formula, most of the cases we have to use this also. If you use 1, you have to use 2 formula. If you use formula number 3, also you have to go back to the formula number 2. So most used formulas are a square minus b square. 4a square looks like a, 2a minus 1 looks like b. Then you have to write 4a square as a plus 2a minus 1 is b. I have kept them in a bracket because there comes problem while we write about minus. Let us see how. A plus b, a minus b. So the students who understand the meaning of minus, they will automatically change this minus as plus, but for those who don't know, better to give bracket first and change in the next step. 4a square plus 2a minus 1. Again here you will get 4a square minus 2a minus times minus plus 1, and we got the factors of first expression. If you think that you can break them, then try yourself, you may not break. Now let's go to the second expression. Second expression is a cube plus 1. Now because there is a power of 3 in the variable a, you can easily understand we are searching for the a cube plus b cube formula. So 8 is a cube of 2, and a you can take as 2a whole cube, and 1 can be taken as cube of itself, that is 1. And now the formula, if it is plus, then there will be plus in the formula and there will be minus in the second factor of the formula. Now you can compare them in a cube plus b cube formula, then you will get 2a as a and 1 as b, a plus b. Again you will get 2a as a square minus 2a, b is 1 plus b square, and that is 1 square. You can open 2a plus 1, open the formula 4a square minus 2a plus 1, and hence these are the factors of the second expression. Now you can match the factors of both expressions. You will find one common among them, that is 4a square minus 2a plus 1. Therefore, the HCF is 4a square minus 2a plus 1, and the LCM is the same, that is HCF 4a square minus 2a plus 1, but the remaining order will also be copied, 4a square plus 2a plus 1 and 2a plus 1, and hence we got the HCF and LCM of the given expressions. So I don't want to make the video any more longer now. We have did 5 questions, and some other questions will also be done in the next video, next coming videos. So till then, don't forget to subscribe this channel, and if you haven't shared this video, please try to share these videos also, so that your friends will also get benefited about the finding of HCF and LCM. So till then, keep practicing, keep learning. Bye.